Alright guys, today we're going to talk about graphical transformations, which is something I'm pretty sure that you did last year with Miss Lachuk, but I'm not 100% sure. So here we go. We're going to pretend like you've seen this for the first time. So all a transformation is, what we did them in geometry, is where you translate, reflect, or we don't say we rotate these, that's later, because then those things don't turn in, those things turn into not functions. But we stretch and compress them, so we dilate them also. So let's talk about, first of all, we're going to have a parent function. Now, a parent function is just one of those 12 basic functions that we talked about last week and you've had a quiz on, and so I'm going to assume you're already familiar with those and what shape they make basically, okay? Now, let's talk about how to transform them. So these are rules, so to speak, of those functions. Okay, so I'm going to, as an example, I'm just going to stick with using f of x equals x to the third, or the cubing function for my parent function. Again, it can work with any of the functions. Anyway, sorry, I paused it there for a second, got sidetracked. So I'm going to use the cube function, the parent function. Okay, now, we're going to translate first. Now, all a translation is just taking the function and shifting it either left and right, or up and down, or both at the same time. So if you want to think about it, as I hate to use the word formula, but general rule, so let's just call it a general rule. I don't like the word formula. If you are moving it horizontally, then you add or subtract the number that you're going to move it by to x specifically. So for example, we say plus or minus. I'm going to use the number or the letter C to represent our number. So you're going to take the function and you're going to add or subtract to the x directly for horizontal. However, it's kind of backwards. The minus is a right movement and the plus is a left movement, like opposite of what you think it should be. And that's going to happen from now until the end of the school year, so kind of go ahead and get used to that. The vertical movement, however, is whenever you're obviously shifting it up or down. But this time, you're going to add or subtract the number to the entire function itself. So you're going to add or subtract, and this time it kind of makes sense. The minus would be down, and the plus would be an up movement. So an example of what that would look like specifically for the cube function. So if I gave you f of x equals x minus 1 to the third power plus 4, and I ask you, hey, how's that cube function moving? You would tell me that because of the inside subtraction, that it is moving or shifting to the right 1 unit, and because of the outside of the function addition, it would be moving up 4 units. Now, if we want to see what that looks like, I'll go to Desmos and type that in. As a matter of fact, that would be really great. Let's go ahead and do that. There we go. Okay, so I'm going to do the parent function first. Y equals x to the third power. So there's my parent function. And then I want to change it. Y equals parentheses x minus 1 to the third power. And then what was it? Plus 4, right? So you can see there that the blue function has been shifted to the right 1 and then up 4. So that's all a translation is it shifts left and right or up and down. Okay, so let's get rid of those. Okay, so let's go back here and talk about a, a reflection. Now there are 3 different kinds of reflections. 2 of them are straightforward, one of them is a little iffy. Not iffy, it's just different. Okay, so reflection is another kind of transformation. And of course we know what a reflection is. This just means it's going to flip it. And so there are actually 3 kinds of flips. In geometry we sort of only did 2. We kept it pretty simple. So if we want to reflect it over the x-axis, so basically it's a flip up and down, then all you're going to do where was I going with that? Is you're going to make the entire function negative. If you want to flip it over the y-axis, which is a left and right flip, then you're going to only make the x values negative. If you want to flip it over the origin, so this kind of, it reflects it over the line y equals x, or it flips it both over the x and y axis at the same time. You literally do both things. You negate the whole function and the values of x. Okay, so an example, of course, for just continuing to use the cube function as my parent function. So like if I said f of x equals negative x to the third power, then see how that's not in parentheses? So negative x to the third power and negative x to the third power, like these two are different. Here it's on the whole function. Here it's only on the value of x. So this particular function, like this one right here, would be a reflection over the x-axis. Now this is actually a pretty poor example because the cubic function, they're both the same for the x and y axis. So if I went and graphed both of them, they would look the same. But I'm going to give you one to try in a minute where they're not going to look the same. Like think of a parabola, for example. If I flip it left and right, it obviously looks different than if I flip it up and down. So that's a reflection, is where your negatives are. If it was the origin, which would be really odd for this one, it would be a negative x to the third. By the way, that's just going to change right back to the parent function for this particular one. That doesn't do it with all of the functions, but again, the cube function's kind of not a great example for reflections, but that's both the negative being on the function and on the x value itself. Okay, and then we get to the stretches and the shrinks, or the compressions, or whatever the word you want to call them. Excuse me. Okay, so these are the, let's just start with the horizontal stretches or shrinks. Horizontal. And these are the ones that are kind of, like I could probably give you a graph of the first two and be like, hey, tell me what happened. And you could be really specific probably. These are the ones where it's a little bit harder to do. And so let me show you. Here we go. That's going to be the easiest thing. So let's look at the horizontal stretch. I can spell stretch. There's two T's in it. Yep. And shrink. Sometimes I'll call it a compression too, just to let you know, because that's what my algebra book calls it, and that's just what I'm used to. Okay, so if you have the function and you are dividing x by a number, if the number is bigger than 1 that you're dividing by, then it is a stretch horizontally. Excuse me, if it's less than 1, then it's a shrink. So let's look, I don't know if this is again going to be another great example or not. So let's look at it graphically. So like sticking to my cube function. So if I said x to the third over 3, right? So that technically would be a horizontal stretch, right? The number I'm dividing by is bigger than 1. So let's look and see what that looks like. Again, I'm going to put the regular parent function up here so that it makes it easier to see in comparison. So y equals x to the third over 3. Okay, so you can see it horizontally stretched. It looks like somebody grabbed the left and right side and pulled it left and right. It's a horizontal stretch. Where if the number was less than 1, okay, so like I'm gonna just change that to a 0.3, right? So see now it's a horizontal shrink. You can see the green was my original and the blue is my is the dilation. It's been squished in. So that's what it means by horizontally, is what's happening left and right. Okay, so let's look at the vertical one. So the vertical one is the exact opposite of that. And then we'll talk about why those are kind of iffy to see. So again, this time, instead of the number being divided, you're going to multiply it. So if I multiply a number times the function, again, this is a vertical stretch or shrink. If the number is bigger than 1, then it's a stretch vertically, and if it's less than 1, it's a shrink vertically. Okay, so that's the same and all, right? That's the same as what just happened up here, but this is vertical and this is horizontal. So let me show you what I mean by that. So if I were to multiply by 3, y equals 3x to the third power. So look at that. That's a vertical stretch. So think about grabbing the top and bottom of the green function and pulling it up and down. That's what it means by vertically stretched. That vertical stretch looks a whole lot like the horizontal compression. And it's because they're kind of the same. And so that's why I say it's difficult to look at a graph and be, oh, this one's this or that, because of how similar they look. And just like, well, let's not add a new one. So let's go back and just say, okay, well, what if I made that 0.3? I did not type in my 0.3. There we go. See, again, that black line, that's my vertical shrink. So again, think of it, and that's why I like to call it compression, because it looks like I've taken the green one and I've pressed down on the top and it squished it. Looks a whole lot like the horizontal stretch. So just be mindful of those two are very, very similar and they're different. So there you go. So those are the graphical transformations. So here's what I want you to do with the rest of your time in class. I want you to use Desmos or not use Desmos. It doesn't really matter to me. But I want you to tell me what's going on with these 4 functions. And I want you to be as specific as possible. Don't just say it moved up or down. Just tell me how by many, what factor did they use, or if it's reflected over which axis specifically, okay? So just think of this as your classwork. And we'll talk about these tomorrow whenever I get back. So the first one, of course, the parent function for this first one is the root function. So if you would like to graph the root function first and then compare it, that would probably not be a bad idea. So here's the first one. The second one's parent function is the absolute value function. The third one, where'd it go? Is the quadratic function or the squaring function. And then the last one is the reciprocal function. Okay. All right, so try those out. Again, it would be my suggestion to graph the parent function first, but totally up to you. And all I need you to do is to tell me in words how those graphs changed from the parent function. Hope you guys have a great rest